right, so welcome back. Number 12, it says a lifeguard earns $320 per week for working 40 hours plus $12 per week over 40 hours. A lifeguard can work a maximum of 60 hours per week. And which graph best represents the lifeguard's weekly earnings for dollars for working hours over 40? So that means he's already earned $320. So he's already worked 40 hours. So we can count off H and we can count off J. The reason we can count both of these is because they both have a y-intercept of starting at 0. Okay? So that would be actually, and look here, it says 40 hours. So that would be starting us working already at the beginning. So these would be two of the graphs for us before we worked overtime. But he's already worked 40 hours. So now we're looking how much he's going to earn by pulling in that overtime and additional money. So now I need to look at both of these, see how many hours. Okay, they both end at 20 hours, so that won't work. Well, I've got a perfect point here, and that means so he worked 15 hours, and I've also got a perfect point there at 10 hours. Okay? Now, the x represents, now what would our equation be? If we're talking about how much he's earned over 40 hours, then our new equation would be y is equal to 12x. Because each hour he works, he's going to make $12. Okay? Now, he's already earned 30, so let's see. Let's say if he worked 10 hours, I'm looking, and I plug that value 10 into my equation. Okay, I'm going to plug in 10 times 12. That will give me 120. Okay? Well, that won't work. Oh, well, plus we have to do the 320 that he's already made. Okay, so 10 hours plus 320 will give us 440. So I'm going to look down here. So here this won't work because that's at 400. So that means that he would have made $400. So that won't work. But here, that looks really close to it. So I'm going to say that the answer choice is G. Now let's check. So let's do 15 times $12. So that gives 180 plus the 320 of these already worked, which gives us 500. So that works in terms of our equation. So we are good to go on that question. Number 13, it says a shoe company is going to close one of its stores and combine all the inventory from both stores. The polynomials represents the inventory of each store, store A and B, which expression represents the combined inventory of these two stores. So that means we're going to add these two polynomials together. So I have to add like terms. Now, so I've got 1/2 g squared plus 7/2, and then I have 3g squared minus 4/5 g plus 1/4. Now look, the g squared, those are combined like terms, but there's no like term like the g. So I'm going to move that over, and that would be plus 0 plus 7/2. Okay? So that now I can see how they're all together. Now let's see, 0.5, and we're going to add all these together. So 0.5, or 1/2 plus 3, will give us 7/2 g squared. Okay, they all have 7/2 g squared minus 4/5 g. They all have, well, I can count out C and D. So now my last choice is to see what the last term is. We have 7/2 plus 1/4, which is going to give us 15 plus 15/4. So our answer choice is A. Now, one of the things, if you don't know how to get a fraction on the calculator, we can do this the long way. So 7/2 plus 1/4. So I need to make like terms. So I'm going to multiply this side by 2. So now that's going to give me 12 over 4 plus 1/4, which is going to give me, That should not be 12, that should be 14. So that's going to give me 14 plus 1, which is 15, over 4, which is 15/4. Okay, the graph of the quadratic function is shown at the on the grid. What is the y-intercept of the graph function f? Y-intercept is where it's crossing the y-axis. That is the coordinate point 0, 0, 4. Now they're probably going to want you to just want the 4, so you'd put 4 on your grid. Number 15, a particular type of cell doubles in number every hour. Whenever we see that double, we want to think y is equal to a times the value of bx. Which function can be used to find the number of cells present at the end of each hours, where there are initially 4 of the cells? So that's going to be y is equal to 4 times, it's doubling every hour, 2 to the value of x. So we're increasing, we're not decreasing. So then, or in the terms of, instead of x, let's use h. So our answer choice is B. Number 16, the slope of a line represented 5x minus 12y is equal to 24. We need to put it in slope-intercept form. So I'm going to subtract 5x from both sides. So that's going to give me negative 12y is equal to negative 5x plus 24. Divide by negative 12. It's going to give me y is equal to 5 divided by negative 12. That is positive 5/12 x minus 24 divided by 12, 2. So our answer choice is going to be J. Which expression is equivalent to 6x squared plus 13x plus 5? Listen, you saw this quadratic formula. We can do factoring, normal factoring. Let's do normal factoring. So I'm going to do A times C. So 6 times 5 is going to give me 30. It's positive 30. B is equal to 13. So let's see. I know 10 times 3 will give me 30. 10 plus 3 will give me also 13. So that works. So now I'm going to rewrite my formula. So let's rewrite this. And I'm going to use these two factors. So we're going to say 6x squared plus 10x plus 3x plus 5. Now in this first two terms, I'm going to look at the first two terms. I can pull out a 3 and I can pull out an x. So then I'm left with a 2x and then I'm left with a, not a 3, sorry, what am I doing? I can pull out a 2x. My apologies. And then that will leave me with a 3x plus 5. Now in this term I can pull out nothing. So plus 1 times 3x plus 5. So now my common factor of this one is going to be 3x plus 5 times 2x plus 1. So that is our factor of C. Now, we could have actually eliminated all of those just by looking at our signs. Because that one has a negative and positive, this one has a negative and positive, that one has a negative and positive. So because our values are at plus and plus. So we would have been able to know there would have been no negatives. So we could have eliminated our answer choices in that way. Whew, yeah. All right, I will go on number 18 on the next question. See you then.